Hi students, welcome to my channel CSIT Tutorials by KanyaKumari. In this video, we are going to discuss minimum cost spanning tree MST. In the previous video, we discussed what is a spanning tree, what are the properties of a spanning tree. Now we are going to discuss minimum cost spanning tree. Let us start with the definition of MST. Now, MST, that means minimum cost spanning tree, is a spanning tree with minimum cost. Minimum cost spanning tree is a spanning tree in which the total cost should be minimum. The total cost should be minimum. What does it mean? So, you know the properties of a spanning tree. If you have not seen that spanning tree video, please watch that video and see this minimum cost spanning tree. Okay. Now, you have different places. Some P3, P4, P5, P6. For example, you have different places are like this. And the waves I am considering like this. Okay. So, you know spanning tree properties. Now, I am constructing one spanning tree like a P1. I am going to P2. After that, I am going to place 6. After that, I am going to place 5. After that, I am going to place 4. After that, I am going to place 3. And then, if you visit this one like this, 3 kilometers distance or 3 hours will take the time. Wait, already wait means here I mentioned in previous video. So, wait means here the distance or time travel from one place to another place. So, 4, 3, 5, 5, 2. Okay. If I represented this one, it is forming a cycle. This is a spanning tree. If you represent this one, it is forming a cycle which is not a spanning tree. Okay. Right. So now, what is the cost? Cost here it is nothing but how much time or what is the total distance I have traveled. So 3 plus 4 plus 3 plus 5 plus 5. Okay. 3 plus 4 7, 7 plus 3 10, 10 plus 10 20 units is the distance. Our total distance to travel all the cities is 20 units. Okay. So, if you can travel in another way also, like P1, I am first writing the vertices. Why? Because number of nodes in the tree equal to number of vertices in the graph. So, first I am writing all the nodes, P6. Previously, we have visited in this direction now. Now I am visiting like this, P1 to P2. Okay. So now P3 to P4 and then P5 and then here and then here. 4, 3, 5, 5, 2. The total distance 2 plus 5 plus 5 plus 3 plus 4 equal to. Now total distance 2 plus 5 7, 7 plus 5 12, 12 plus 3 15, 19. This is also a spanning tree. This is also a spanning tree. But the cost here it is 19. Here the cost is 20. But we will take this minimum cost of spanning tree means this one, not this one. Why? Because the total cost should be minimum. So here the total cost is minimum. So like that. So for a given graph, you may have more than one spanning tree. So, from all those spanning trees, we will consider one as a minimum cost spanning tree. Why? Because the total cost should be minimum. So, hope you understand the definition of minimum cost spanning tree. Now, so how to construct this minimum cost spanning tree? How to construct this minimum cost spanning tree? There are two algorithms for constructing minimum cost spanning tree. So first one is Kruskals algorithm. First one is Kruskals algorithm, and then Prim's algorithm. There are two algorithms to construct a minimum cost spanning tree. One is Kruskals algorithm, second one is Prim's algorithm. So now we are going to discuss the first algorithm, Kruskals algorithm. Let us start the Kruskals algorithm. Okay. Now, in the Kruskals algorithm, for example, how to visit all the places by using Kruskals. Consider the graph. For example, what is I am taking? V1, V2, V3, V4, V5, V6. For example, this is the given graph. Assume these are the cities. Okay. For example, this is the graph. I am writing the costs. Costs are nothing but the distances. Suppose here it is 2, 3, 1, 2, 3, 3, 2, 2, 4. Okay. Now, what are the steps for constructing minimum cost spanning tree for this graph? So, first step is represent cost table. Represent cost table. That means first, what is this table? You know, table means rows and columns are there. Now I will represent the columns. What are the column names? Here I will write edge. Edge is present between which two vertices? Okay, edge, and what is the cost of that edge? Okay, first I am writing. So ordered pair V1, V2, and the cost is to this one. Next V2 to V3, V2 to V3, this is one. Next V2 to V4, it is 3. Next V3 to V4, 2. See, V3 to V4 or V4 to V3. Why? Because this is a unidirectional graph. It is not a directed graph. It is a undirected graph. Okay. So next V3 to V5. This we represented. This we represented. V3 to V5. Suppose. Now if I am writing like this now. So now what we have to do is actually we have to write all this. This is generally cost table. But this cost table we will represent in ascending order. So first writing all the edges, then writing in the ascending order without doing like that. So now you can write this cost table in ascending order of edge costs. Ascending order of edge costs. That means now see I am removing all this now. So I will write in ascending order. Okay. Now see, then it is easy. Okay. First, what is the minimum cost? Here it is 1. So first I am writing V2, V3, 1. Okay. Next minimum cost. 2, 2, 2, 2. 4 edges are there. So V1 to V2, 2 units. Then this we have represented. Then V5 to V6, 2 units. This edge we have represented. Then V3 to V6, 2 units. Then V3 to V4, 2 units. So 1, 2, 3, 4 covered. Next edge cost, next minimum is 3. It is again 3. So one is V2 to V4, V2 to V4, 3 units, V4 to V5, 3 units, then this one, V3 to V5, V3 to V5, 3 units, and then 4 units, V1 to V6, 4 units. Okay. Now after writing this edge cost table in ascending order of their cost, now we will check one by one. We will represent a spanning tree. So now see, in the spanning tree, write the nodes V1, V2, V3. First write all the vertices V4, V5, V6. Okay. So check one by one first. Add that edge to this spanning tree. This is called as a forest, a collection of trees. This is one tree, this is one tree. Now we are combining all these trees to get a final tree. Okay. So one by one edge we will add in such a way that it should not form a cycle. Why? Because minimum cost spanning tree means it should not form a cycle. So add one by one. V2 to V3, 1 unit. V2 to V3. So V2 to V3, 1 unit. Yes, it is not forming a cycle. That means this is added to the forest. Accepted edge. Next, V1 to V2, 2. V1 to V2, 2. It is also not forming a cycle. You may get doubt. So 2 if you have added, shall we consider remaining 2 edge costs or not? Yes, we have to consider. Okay. So now this also accepted because it is also not forming a cycle. Next, V5 to V6. V5 to V6. The cost is 2 units. Yes, it is also not forming a cycle. So accepted. Next, V3 to V6. Yes, V3 to V6. Here also it is not forming a cycle. V3 to V6. That is also added. Next, V3 to V4. Yeah, V3 to V4. What is the cost of V3 to V4? It is also 2 units. That edge is also added to the forest. So accepted. Now, V2. This one. Okay. Next, V2 to V4. V2 to V4. See, if you have added that V2 to V4, now see, if you add V2 to V4, it is forming a cycle if you observe. So we should not add. That means it is rejected. V4 to V5. V4 to V5. If you add this one also, see, it is forming a cycle. That means it is also rejected. V3 to V5. V3 to V5. If you add this one, it is also forming a cycle. So, rejected. V1 to V6. If you add this one, that is also rejected. So, these are accepted and these are rejected. So, now, see, these are not added to the forest. Now, this is the final spanning tree. V1, V2, V3, V4, V5, V6. V1 to V2, 2 units. V2 to V3, 1 unit. V3 to V4, 2 units. V5 to V6, 2 units. And this is 2 units. Now, what is the total cost? Which is minimum? Total cost equal to 1 plus, see, 1, 2, 2, 2, 2. 4 times 2. That means 8. So, total cost is 9. So, the minimum cost taken to travel all these 6 cities is 9 units is the cost by using Kruskals algorithm. So in the Kruskals algorithm, what are the steps here? First we will represent the cost table in ascending order of edge cost, and then we will add one by one edge to the forest. If it is not forming a cycle, then we will add that edge to the forest. If it is forming a cycle, we should not add to the forest. Like that, repeat the process. So now see, if you observe, whatever the edges we have not added, if you add that edge, definitely it is forming a cycle. It is forming a cycle. So this is your minimum cost spanning tree for the given graph G, and that with the total cost 9 units. So this is your Kruskals algorithm. Hope you understand, students. If you have any doubt, please post to me your doubt in the comment box. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.